Question says the graph of f of x equals 3 times x minus 2, and it's translated up 1 unit. Translated just means it's moved, so the graph is moved up 1 unit and left 3 units. Write the equation of the translated function r of x in slope-intercept form. So the first thing I want you to notice is this is a linear equation. So we have an x here. It doesn't have an exponent on it. So this is going to be linear. So if on the original question you weren't given a graph, but I'm going to answer this by using a graph. Now I've got a nice perfect graph here, but if you were doing this yourself, you could just sketch something really simple on a scrap piece of paper and do what I'm going to do. It doesn't have to be a perfect graph. That's what I want you to see. So as I do this, hopefully you can see you could just make a little sketch and it doesn't have to be perfect. So the first thing I want to do is I want to see what this line looks like. And again, instead of trying to visualize it in your head, I'm going to put it on a graph. And again, it doesn't have to be perfect. Okay. So I'm going to take this function, f of x equals 3 times x minus 2. And I'm going to put it in slope-intercept form. Slope-intercept form looks like this. Y equals mx plus b, where m is the slope and b is the y-intercept. So to do that, I'm just going to simply distribute here, get rid of the parentheses. And so then I'll have f of x equals 3x minus 6. So the slope of the line is 3 and the y-intercept is negative 6. So just again, I want to do a quick sketch of this. So I know it crosses the y-axis at negative 6. That's what the B tells me. So I can put a dot on my graph at negative 6. And then the slope is 3. So for the slope, I'm going to use rise over run. So rise over run. And so I'm just going to rewrite the slope as 3 over 1. So that's the same thing as 3, right? So from this y-intercept, I'm going to rise 3 and run 1. And this is a positive slope, so I know the line's going to lean to the right. So I go up 3 and over 1 and put a dot there. And I could put a line through this, but I'm terrible at drawing straight lines. Oh gosh, okay, I'll try my best. This is going to be bad. That's pretty terrible. Again, it's even worse now. Again, it doesn't have to be a perfect sketch, all right? Because I'll show you what we're going to do here. All right, so now I have an idea of what this looks like. And that's really all I wanted was an idea of what the graph of this function looks like. Now, hopefully you can see that if I took this line and I moved it up a unit and to the left 3 units, that would just give me a line over here somewhere. So I would go up a unit, left 3 units, and the line would be like this. And hopefully you can recognize that they would be parallel. So they have the same slope. So to write the equation of r of x, I already know the slope. It's 3. So what I need to find is the y-intercept. So here's what we're going to do. I'm going to take the y-intercept of this one and I'm going to translate it up 1 unit and left 3 units, and that's going to give me a new point for the new line. All right, so let me do that. So from the y-intercept, I'm going to translate it up 1 unit and over 3. 1, 2, 3. So that would give me a dot right there. Okay. So now I know this line, well, I'll try to sketch it. It's going to not be pretty. Oh boy. It's parallel to the other one. And so to write this equation, all I need to know is where the y-intercept of that line is. So I have the slope because the slope is the same as the first one. So the slope is 3. I have that piece. Now I just need the y-intercept. Now, obviously, you can't look at my little sketch here and tell what the y-intercept is. Again, that's why I said this doesn't have to be perfect. But what I'm going to do is I'm going to take the coordinates of this new point. And so I went up 1 and over 3. And the coordinates of this point are going to be -3, comma, -5. So now I have a point on the line, and I can use that point to find the y-intercept. So how am I going to do that? Well, I'm going to take my y equals mx plus b. I know the slope is equal to 3 for my new line, so I'm talking about r of x here. Let's label that. I know m is 3, and I know that it goes through the point -3, -5. And again, I know that because I took a point from the other line and I translated it using what they said. I translated it up 1 and left 3, and that gives me a point on the new line. So I have a slope and a point. So how am I going to find the y-intercept? Well, I'm going to take this point, this is an x and a y value, and I'm going to plug those in for x and y in slope-intercept form, and I'm going to plug in 3 for m, and then I'm going to solve it for b. That's how we're going to do this. So I'm going to so let me first label this. This is an x and this is a y. So I'm going to take all of this information and I'm going to plug it in to slope-intercept form, y equals mx plus b. So I plug in -5 for y, -5. M we said is 3. It's got the same slope. They're parallel. X is -3. And then I have plus b. So now let's solve this for b. So now I have -5 equals -9 plus b. Add 9 to both sides of the equation. Plus 9. So that'll go way over here, and over here I'm left with 4. So my b value is 4. So I have my y-intercept, and I have my m. And so now I just simply write the equation, plugging those in. Instead of y equals, I'm going to use what they gave me, which is r of x in function notation. And so that's equal to mx, so that would be 3x, because my slope is 3. And then plus b, so that's plus 4. And so there is the equation of the translated function. All right, there's quite a few steps in there, so you might want to back up and watch that again. But hopefully that helped you out. Keep working hard. You're doing great. You're on your way to mastering the math.